So today we're actually continuing on in lesson 4. Yes, Katie? So we're continuing on in lesson 4 today, and in lesson 4. So this will be something that can be on the quiz tomorrow. These become part of your notes, and you do get to use your notes on tomorrow's quiz. So you're going to want to be tuned in here and making sure that you are understanding this. Okay? So we have worked with data sets already. We have found the maximum, the minimum, the mode, the range, the mean, the median, all of those values we've been able to find for a data set, right? Well, we're going to talk about today data sets with outliers. So what's an outlier? Well, an outlier is a data value that is far removed from the rest of the data values. Fill in the blanks. It is a data value that is far removed from the rest of the data values. So the other ones kind of look typical of each other. They're kind of all in the same kind of region of the number line. And then there's that 1 or that 2 or whatever that are like a long ways away from them. They're far removed, we call them. Okay? So examples. Here's my data set. 2, 26, 28, 32, 35, 39. Look that over. Do you think any of those are outliers, or they're kind of like a much further away from the rest of them? What do you think, Wade? 2. Yeah, 2 is down there way at the end, and 26 through 39, there's not such a big range there, but there's a big range between 2 and 26, isn't there? 20 something. So we would say 2 is an outlier in this data set. Okay, how about the next data set? 30, 40, 31. 100, 36, and 39. Harley, what do you think? 100. Yeah, 100 doesn't look like it's typical of the rest of those numbers. We would say it's far removed. We would call 100 an outlier in that set. Okay. So here's what we're going to do. We're going to find the median and the mean of each data set, because we want to decide, you know, what does an outlier do to the data set? Why is it such a big deal if there's an outlier? Okay? So in this first one, the first set that we said 2 was an outlier, it's already in order, isn't it? So it's ready for us to find the median. So will you find the median of that data set, please? 2, 26, 28, 32, 35, and 39. What is the median of that data set? Well, 1, 2, 3, 4, 5, 6 pieces of data. Oops. Can we land on the middle number? What do we do when we can't land on the middle number? Derek?
From the outsides.
You go from the outsides in, and you know where we're going to land? We're going to land right here, aren't we? Yeah, so what do we do with that? What do we do with that? Wait. No, we don't divide 32 by 28. That would not work. That would not work. Tyler, can you help us out? Multiply. No, we would not multiply them either. So, sticking over here, we're going to give this row one more chance. Hannah? You would add them together, first of all. So the first thing you need to do is you need to add them together. So 28 plus 32, and what is that? That's 28 plus 32, Dan? 60. Okay, so is 60 the median?
Yeah.
No, now what do we have to do? Go ahead, Sam. Divide by 2. So what we're really doing, so 60 divided by 2, well, what's 60 divided by 2? Class? 30. Okay, so what we're really doing is we are finding halfway between the two numbers in the middle. Does that make sense? That 30 is halfway between 28 and 32? Do you agree? And on the number line, 30 would be halfway between 28 and 32. That's our median then. When we have two data values in the middle, we have to find the middle of those. Find halfway between them, so that's what we need to do. Okay, mean. What do we have to do to find the mean again? Keaton?
Add them all together and divide by how many numbers there are.
Yeah, add them all together and divide by how many numbers there are. This is where Kate's going to be counting on you guys because you're going to add them all together and get a sum. Where's your calculator? Yeah, take care of that, Derek. Take care of that. Take care of that. Take care of that. Take care of that. Oh. Ooh. almost half of you. What's going on here? Okay, what's the sum? Who's got it for the rest of this class that doesn't have their calculators? Cheyenne?
162.
I'm sorry, how much?
162.
162. Do you guys agree with her?
Yeah.
Okay, 162 is the sum, and we have to divide by how many data values are that? There are, how many are there?
2.
6. There are 6 altogether. Okay, go ahead and divide that out. What is 162 divided by 6, Harlan? 27, she says. Will you check her out and make sure? You all agree? Okay, so we'll circle that and say that 27 is the mean. Okay, now, I just want us to stop for a moment. I want us to look at where the mean would fall in this group of data right here. It would be right in here, wouldn't it? There's really only 2 values that are less than the mean, and the other 4 are greater than the mean. Okay, so let's just like make that observation right now. Now what I want us to do is I want us to find the mean without the outlier. So we're gonna ditch the outlier. What's our outlier again? 2. So leave out 2, and I want you to add the other 5 numbers together. Or in other words, does anybody know a shortcut how we can figure out the sum without the outlier? Subtract what? 2 from 162. Yeah. So what's the sum without the 2? 160. So without the outlier, but there's not 6 pieces anymore because we ditched the outlier. So how many are there? 5. So we're going to divide by 5 this time. So tell me, what's 160 divided by 5? What's that? Tyler? 32. Okay. So now I want us to observe where the mean is when we leave the 2 out. So in other words, basically what I'm saying is we just worked with these numbers right here. And where's the mean now?
Lane Moffitt to the senior high office, please. Lane.
It's kind of more in the middle of it all. It's more typical of the data, isn't it? So what did the 2 do to the data set when we're talking about the mean? What did the 2 do? Did it make the mean too high or too low?
Too high.
Okay, what it was with the outlier in it was 27, and with it not in it, it was 32. It made it too low, didn't it? It made it too low. So the mean got lowered because of that 2 being in there. So we would say in this case, the median is a much better representation than the mean is for that data set. We're comparing mean and median. The median is a better representation for this data set because it's a better picture of what's going on. The outlier, 2, made the mean too low. Okay? Let's do our other one. Well, is that one in order? No. So the first thing we're going to do is get that data set put in order. Would you do that, please? Get that data set put in order. Oops, I put mine in the wrong spot. Nice. Erase it all now. Okay, here's an order. Okay. What's the median? And how are we going to get it? Do we land on the middle this time again? This time we do? So Wade, what happens when we look for the median?
Well, it's a even number of numbers, so it would be 36.
Yeah, it's an even number of data values, so you're not going to land on one number right exactly in the middle. You're going to have to find the average. You're going to have to find the middle of those numbers, aren't you? So what are we going to do again, class? Add those. Yeah, add those together. What do we get when we add 36 and 39, Danny? 75. Is 75 the median? Remember, would 75 be halfway between 36 and 39? No. divided by 2 now, so 75 divided by 2. Who's got that for us, Tyler? 37.5 or 37 and a half. Does that make sense that 37 and a half would be halfway between 36 and 39?
Yeah.
No. Yeah, well, let's see, 36 plus 1 and a half. What's that? Oh, that's 37.5. How about 39 take away 1 and a half? Oh, I think it is halfway between, isn't it? Sure is. It's equal distance from both of them, so 1.5 units from both of those, so I would say that's halfway. Now, some of you, the problem you have with median is this: you are not putting them in order first. Do you have to?
Yes.
Absolutely you do. You can't find the middle of the numbers when they're not in order. Okay, so you have to do that. Okay, find the mean for me. What's the mean? Find the mean. Add up all the numbers and tell me what the sum is first of all. It's the sum of the numbers. Cheyenne, what'd you get?
276.
How much?
276.
Okay, so you guys all do it so you can tell her if she's right, because I'm going to count on her being right and you checking her out for me. 276 she gets. Did you get that? Calculator people? You got some head nods, yeah? Okay. What are we going to divide that by? 6. Because why? Why are we dividing by 6? Because there's 6 data values. Okay, so what is 276 divided by 6? Danny? Pardon? 46, she says. You guys agree with her? Yes? Okay. So our mean is 46. Now I want us to look at our list of numbers when they're in order. Where would that 46 be at? Way up here. Is that a little high, do you think? For an average? So let's do it without the outlier. What's the outlier in this one? 100. So what's the sum going to be without the 100 in it? We're going to take the 100 out of the sum, Harley. 176. Instead of 276, it's going to be 176 now. How many data values do we have now? 5. So now we're going to take 176 and divide it by 5. What's that going to be? We're going to take 176 and divide it by 5. Yeah? 35.2. Okay, everybody agree with her that has the calculators here? 35.2? Yeah. Okay, so 35.2, let's go see where that would be. Oh, that'd be like down more, really close to this 36 right here. Does that seem like a better average? It really does, doesn't it? So what did the mean do this time? Or the outlier do to the mean this time? It made it what? Too high. It made it too high. It should be more reasonable, like 35 and 2/10, 35.2. So in both the median, we would say, because the median in this one was 37.5. I'm sorry, the mean here was 46. So the median was 37.5, which is much more typical of the data. So the median is a better description because the outlier makes the mean either too low or too high. It throws the mean off. So when there's an outlier, we probably want to count on the median as being a better descriptor of the data than the average, the mean. Does that make sense? Why we want to throw that outlier out when we're talking about what should we do? We should talk about the median then rather than the mean. Okay, that's all the notes that we're going to take today, and you're not going to do any practice in your notebooks.